Welcome everyone back to another posted clip on our Buchanan County tour. I'd like to introduce Brian Keierleber, Buchanan County Engineer. These postings are part of our local agency Bridge Innovation and Demonstration Days. Typically when we do this on site, we go out on a tour of the county and look at their concrete bridges, their steel bridges, their wood bridges, and their rail car bridges. This link in this presentation is going to be about the steel bridges in Buchanan County. Brian, you are up.
Good day. Well, it's always a pleasure to talk about bridges, and we're going to start out with some buried soil structures. And I've got 3 of them now. We've all heard the comment, why not just throw in a culvert? Well, people don't realize how much area you need quite often. And so this is kind of as close as we come. Now, we've done some multi-plates in the past. And with the multi-plate, you do have a flow line thrust out. Well, with the buried soil structures, you don't have any of that. So what you can do is you can look at what you need for footings. There isn't any structure any better than what's got underneath it for a footing. What I've done here and a couple other times is I've gone and left the old wood piling in there, because that's typically what brought the end of that bridge to its demise. And we all know that if you cut that wood piling down about a foot below the water line, or where it never got any air, it won't decay. That piling's as good as the day you drove it. And then to get a little extra strength, again, you got to know your soil so you know what'll handle, is I went a little wider on my footing there, so I got a 4-foot wide footing, incorporating the old wood piling. Now, the old wood piling didn't go out wider than the road right away, speak of, and with this I went about 10 foot wider. So what I've done is I've extended that footing out there, and where it's just dead load, I don't have any piling underneath that, and I use the old wood piling where I can. The key to that is if I can still get the capacity in this channel that I need. This happens to be a 26-foot structure. Excuse me, the wrong buried soil structure. It happens to be an overflow structure, so it doesn't have water going through it on a regular basis. And that made this an ideal answer where it's at. And I put the riprap in there to make sure I never scour out. Now, one of the key things on all of these is when you're backfilling, you have to backfill a little bit on each side and compact on each side as you're going up, so you keep it symmetrical. Otherwise, you can actually start shifting, pushing your structure where you don't have a uniform arch on it. This is the 26-foot structure here, and this one does have water going through it all the time. And I did pretty much the same thing here, and again, I used the existing wood piling that were in place. I was able to get the flow through there. Recently, we had some 3 to 7 inch rains up in this area, and it was flowing pretty close to the top, about a foot and a half away from the top of this arch. And it's a 26-foot structure. It's handled it well. I didn't back the water up. Like I said, though, it was flowing pretty heavy. And there was reports of 6.5 inches of rain upstream from this. So it handled it well. Again, used the old wood piling, used a 4-foot wide footing because the soils were good enough that I could do that, extended out wider than the roadway. And again, why we do this is purely for economic standpoint, looking for a better way of doing things, the more economical way of doing it. And this is in the right environment. This is a very good answer. You can see the approach roadway coming in. We try to get it 10 feet outside each side too. And so that means with that kind of span and that skew on there, we squeezed our road right-of-ways without a doubt. You can kind of see where the utility poles are in there, and that's generally about the property line. And you still have to get that water coming in the side. Sometimes we'll throw another culvert in on the side there, and we can fill that in there, and to keep within our right-of-way rather than buying road right-of-ways. they don't want to give it up, and we don't want to have to buy it, so the best we can do to build within it. And again, we don't want to scour out, so what we'll do is we'll put some riprap in on that footing along the footing. And that is a 4-foot footing, so we're down there deep enough that I shouldn't have any issues. Also, that's incorporating the old wood piling. Like I said, we know when we get down there below, it's good. This is a joint project with the short span steel industry, and it was the first time that the eSpan 140, which is a computerized design system that's free to our use. And so this is really a learning experience for me. This bridge happens to be on a road that carries 4,360 vehicles a day. And we built this bridge with the county employees. So it was a major undertaking, and we had a lot of partners in it from the short span steel industry, and that plaque there kind of represents them. And I'm not going to try and name them, or I wouldn't get all the way through it. But if you're curious, just go to the Short Span Steel Industries website. You'll get some of that information. And there's even some videos and such available on building this bridge, and it was with the county employees that it was built. Some of the key things that incorporated in there is that barrier rail system on there is an MGS barrier rail system. So that's another metal bolt-on barrier rail system, which simplifies the construction. This happens to be 68 feet long and 40 foot wide. Again, on our paved roads, we're trying to get wider bridges that way to make it safer and try to be building long-term for the future. You'll notice we also had the texture that you'll see some joining in there, and that's partly because of the bridge and our approach slabs tying everything in. Another thing you'll notice right there is the texture on that. That was tied in texture. On the county system, that's good enough. Also, we've gone to 6-inch wide pavement markings because of accident reduction. The little safety features that we've been doing are truly making a difference with a significant reduction in crashes on the county road system here in Buchanan County. This one does have the different terminal intersections, again, because of the location and the traffic volumes. And you can kind of see. Now, one of the key things about this bridge is it has galvanized rebar. I've read some studies that the galvanized rebar dramatically reduces your maintenance on your bridge decks and extends the life out. They do talk in the vicinity of a 100-year life. The galvanized rebar dramatically extends the life of your bridge deck out. And they do talk in the vicinity of a 100-year life on these bridge decks from some of the studies. And then what I've also done is I put in a galvanized steel beams. Those are rolled beams that are hot dip galvanized. And this bridge, we've tried to incorporate as many of the R19 things in there as we could to try and get that 100-year life out of this bridge. I'm a true optimist that we should be able to do that if we can keep the concrete to last that long too. And you'll see some of the beams on here and the galvanizing. To hot dip galvanize a beam that long, they have to double dip it. And so if you look about right there, you see a little diagonal mark, and that's from dipping one end and then dipping the other. But they can cover that up if you want. In my case, we're not looking at the aesthetics, we're looking at the life on these structures. I shouldn't say looking at the aesthetics, but no, but the people that crawl underneath there don't have to worry so much about that. It does have integral abutments, so that you won't have any of the expansion issues to be concerned about. This particular case, this is now a Nucor Yamato joint project, and this is grade 65 steel beams. Now, the key on a grade 65 steel beam is the fact that it's 30% stronger at only about a 5% more cost. And every day is a learning experience to me too. And hindsight being 2020, I really wished I'd spaced my beam spacing a little closer, and I would have used steel beam planks because for decking, and not had to pour the concrete deck on this. This again has the SL1 barrier rail system on it, which is a simple barrier rail system for crash level 1 tested. So we're perfectly fine with that on these low volume roads. You'll also notice that I'm wider than the approach roadway, and so I can get by with the flexible posts on that. We put a little sleeve in there because they're going to get hit too with this wide farm equipment in these areas. And you can kind of see the channel coming in, and even if you look at it, it's been kind of raining on and off all the time here. These have a zinc paint on these particular beams. As we get down into the channel, we'll start seeing some of the beams. We used a galvanized sheet metal for the wings and the abutments, and a zinc coating on these beams. And again, this is the SL1 barrier rail system. We poured a 3x3 cap on top of our sheet metal abutments. You see the diaphragms in there. Like I had stated earlier, hindsight being 20/20, I really wished I'd kept that spacing on those beams a little closer and used the metal stay in place, or beams, the decking beams, and then covered it with road rock, and it would have been a more economical answer and worked perfectly fine in this environment. You can see my neoprene bearing pads in there, and there was a little more deflection on them than what I was expecting to be seeing. Again, it's a nice clean structure. This is the Nucor Yamato grade 65 steel beams. It was a partnership with them that we built this bridge, and a really good experience. And like I said, hindsight being 20/20, in the future I hope to be building some of these using the stay in place, or the metal decking beams. And again, we tie across. We'll have some bolts all the way across. This is the press brake tub girder. So this is the Amish Sawmill bridge. And in this case, they take steel plate, and about an 8-foot wide steel plate, fold it into a box shape, put shear studs on it, galvanize it, and turn it into our bridge beams. This was the first one done with this design, and I fully expect it to be one of the more common designs in the future. And I'll explain what's going on. It's the economics of producing the steel and the economics of the system. Now, at the time this was done, they were starting to get set up to do mass production of these, but as it was, this wasn't. It was parts were made in Ohio, and the press braking was done in Ohio, and the steel was actually fabricated, the steel was produced in Iowa and sent back to Ohio. And so the hot dip galvanizing, I think, was done in Illinois. So it moved around a little bit. Well, now it's getting set up where they're actually producing these here in the Midwest, and they're putting the concrete deck on them and sending them out and having them all ready for you to tie together with a UHPC or a similar material. Now, this again is the galvanized sheet piling. This one happens to be, that's an access port in case somebody wanted to do inspection port, not an access port, inspection port. In case somebody wanted to inspect the inside of these beams to see how they're doing, even though they're galvanized on the inside too. That was a metal stay-in-place decking that was used on this. In the future, like I said, they'll be prefabricated and brought out. This is sitting on fabric abutments, or GRS IBS abutments. And we've had very good luck with that. With the GRS IBS, we've got a half a dozen bridges that are sitting on that now and have absolutely no problems on any of them. You can see the corn stalk shoved up in there. We've gotten some major rains in the past few years, and this looks like a nice, almost dry structure right now. And 48 hours later, it could be an entirely different story. Again, a very good, clean structure. The sheet piling abutments is a simple way of doing it. The vibratory drivers that they have nowadays will sink those in clean, fast, and then you turn around and put your fabric burrito wraps behind them. That takes all your pressures off of that wall, so you don't have to have everything tying it in, and you don't have to have near the strength of sheet piling as you would otherwise. Again, this happens to be the SL1 barrier rail system. We've used 3 different types of bolt-on barrier rail system. The Jessup South steel bridge there was used in the MGS barrier rail system. You'll see how that's barrier rails bolted on, and then even on your approaches, you just put in a post and off the bridge. And even out here in the rural Amish community, this is called the Amish Sawmill Bridge, and that is an Amish settled house right behind it, and they have a sawmill there that the Amish run. Sheet piling wings, and to keep from buying additional road right away, we would pull the drainage right down the ditch, throw some culvert in. This happens to be where we've gotten to. This is the Buffalo Creek Bridge, otherwise known as the Cyclone Bridge. And the key there is the bridge downstream I built in 1997, and I'm going back and doing repairs on the piling and casements. And so the thoughts were, well, rather than going back in there and repairing these bridges, I think of this Einstein fellow who had the statement that insanity is doing the same thing over and over again the same way and expecting different results. And I keep thinking that we got to find a better way of doing these pilings. So what I did was I galvanized and coated the H piling. Right now you're seeing a view of the Wyoming barrier rail system, and I really like this system on these paved roads, because they have the conduits that drop the water or the road waste off there, and we use a tremendous amount of salt here in Iowa, so that'll get that off. We're having some trouble with some of our concrete slab bridges where that salt will migrate around, and so this is a solution to that. These again are galvanized rolled steel beams. And then the H piling in this case are galvanized and coated. That happens to be a Cyclone Red. Hence the name, the Cyclone Bridge. What this design did for us is that they started this project in the fall of 2018. I say fall, it was late summer. And it started raining. And it never stopped raining hardly. And they would get a little bit of a breather, and they could come in and drive the piling. But had they ever if they had to build cofferdams to do the piling and casements, this bridge would not have gotten completed that fall. It would have gotten completed in the spring or summer of 2019. Now, those of us in Iowa, or actually in the Midwest, remember what the spring of 2019 was. It was frost boil galore. And trying to detour traffic from this paved road onto rock roads around would have been a complete disaster. And so the fact that it got completed December 24th of 2018 instead of July 1st or somewhere in that time frame in 2019 was a tremendous savings. And that's why we have a little presentation on this bridge, and Krista Taylor is going to be speaking some. She was the contractor on it. And so we're looking for ways of building better bridges, and this may be one of those methods. Now you notice the splice on these beams because this is a continuous span, and maybe the right answer is a heavier beam and design them as a simple span. What we got to recognize is that labor costs in today's world are a bigger factor than the material costs, and we don't expect to see that changing a whole lot. If anything, I would expect it'll get worse. So we need to look for better ways of doing it, and that's something we need to evaluate in the future, whether we need to change some of our designs. Again, the galvanized and coated H piling, the experts on that tell me that we should get close to 100 years of life out of that. Well, if I'm going back in, bridge is 97 downstream a mile, and doing repairs after 23 years, It'd be the same thing here if I had to come back in the future and start doing some repairs on these piling. I'm hoping that that's not the case, that I'll get that kind of life out of the 100-year life out of it and not have to make any changes.